What is the area of the red regular hexagon? Trigonometric identities, properties of regular hexagon, right triangle, basic arithmetic and algebraic processes are used to solve this question. Join line B, F and line B, D. Since CDEFAB is a regular hexagon, n equals 6. This implies that n-2 multiplied by 180 degrees, which equals to 6-2 multiplied by 180 degrees. The final result is equals to 720 degrees. The interior angle of regular hexagon equals 720 degree divided by 6 equals 120 degrees. It implies that angle BAF equals angle BCD, which equals 120 degrees. Triangle BAF is isosceles triangle. This implies that angle ABF equals half of 180 degrees minus angle BAF, which equals to half of 180 degrees minus 120 degrees. The result is equals to 30 degrees, which equals angle BFA and angle CBD, respectively. The reason is that triangle BAF is congruent to triangle BCD. Hence, angle FBD equals angle ABC minus 2 times angle ABF, which equals 120 degrees minus 2 times 30 degrees. The result is equals to 60 degrees. Let angle MBAB equals to theta. Since angle MBN equals 180 degrees, it is because sum of angles in a straight line equals 180 degrees. It implies that angle NBD equals 180 degrees minus angle DBM, which equals to 90 degrees minus theta. As shown on the screen, we call it equation Y. From right triangle AMB, let line B, AB equals to X. This implies that line BA equals line BC, which equals to line CD. The result is equals to X. This is because side lengths of a regular hexagon are equal. It signifies that line MA divided by line BA equals sine theta, which equals to 3 divided by X. Hence, 3 divided by X equals sine theta. We call it equation 1. Consider triangle BCD. Using cosine rule, the square of line BD equals 2 times the product of the square of line BC and 1 minus cosine 120 degrees. Substitute values. We have that the square of line BD equals to 3 times the square of X. Find the square root of the equation. We have that line BD equals X times the square root of 3. We call it equation 2. From right triangle DBN, line DN divided by line BD equals 5 divided by line BD, which equals to sine 90 degrees minus theta. The substitution is obtained from equation Y. Substitute equation 2. 5 divided by X times the square root of 3 equals sine 90 degrees minus theta. We call it equation 3. Divide equation 1 by equation 2. This implies that The ratio of 3 divided by x to 5 divided by x times the square root of 3 equals sine theta divided by sine 90 degree minus theta. Simplify and we obtained equation G. By trigonometric identity, sine 90 degrees minus theta equals cosine theta. After simplification, substitute into equation G. 3 times the square root of 3 divided by 5 equals sine theta divided by cosine theta, which equals to tan theta. The relation is derived from trigonometric identity. This implies that tan theta equals 3 times the square root of 3, all divided by 5. Also, 1 plus the square of tan theta equals 1 divided by the square of cosine theta. Substitute values. This implies that 1 plus the square of 3 times the square root of 3 divided by 5 equals the square inverse of cosine theta. Solve for the square of cosine theta. We have that the square of cosine theta equals 25 divided by 52. By trigonometric identity, sine theta equals the square root of 1 minus the square of cosine theta, which equals 3 times the square root of 3, all divided by 2 times the square root of 13. After simplification of substituted values. Substitute into equation 1. 3 divided by x equals sine theta, which equals the product of half of 3 and the square root of 3 divided by the square root of 13. Cross multiply and solve for x. This implies that x equals 2 times the square root of 13 divided by 3. Locate center O of the regular hexagon. Join line OB and line OC. BOC is an equilateral triangle. Since 6 triangle BOC equals area of red hexagon, therefore, area of red hexagon equals half of 6 times the square of x multiplied by sine 60 degrees, which equals to 26 times the square root of 3 in square centimeters. After simplification of substituted values.